Oh, hi. Bob and I decided to take a little walk and get out of the garage for a moment or so. And so we got out here and started walking, and then Bob said, I'm hungry. Well, I said, Bob, we're out here in the middle of nowhere. We don't have a stove, we got nothing. What are you going to do? Well, lucky for Bob, we brought along an MRE. What we want to do then is, oh, it's starting to rain. What we're going to have to do is go inside, and so we can show you what exactly is in an MRE and what's it got to do with our science class. All right, so we'll see you inside. Well, we're back inside. We were taking a little break there outside, and it started to rain. And so we're going to have Bob here with his MRE show you what exactly does this have to do with us in our science class. Well, in order for people to eat these, you have to be able to heat these. And how do you heat them without a fire? Well, that's where chemistry comes in. So let's take a look at this. What exactly is in here? Well, we opened it up, and we have, there's a beef snack strip. That sounds like fun. We have a tea bag, Tabasco sauce. We've got chiclets. We've got a hand wipe. We've got matches in case Bob wants to set something on fire. We have fudge brownie. Yeah, that sounds good. Military rations are good performance meals. So this, oh, beef ravioli and meat sauce. Yeah, there you go. And here we have mixed fruit. Okay, that sounds good. We also have what we're looking for. Yeah, there's a camouflage spoon. Always use one of those. What else is in here? Oh, cheese spread. That sounds good. That's got to be nutritious. Ha! Here's the thing we're looking for. This is, oh, and crackers. Oh yeah, crackers. This is the flameless ration heater. This is the thing that's going to heat this thing up. Okay? Now, this takes about 15 minutes, so we'll kind of look at the beginning of it, and then we'll let Bob take care of this, and I'll show you the chemistry of what's going on here. Okay, so everything Bob needs is here except water, and I just happen to have a canteen here that's got water in it. And the other thing Bob needs is, oh, he's going to need something to lean this against. We'll see what we can find there in a minute. They want us to tear one of these apart. Open it up here where it says tear it here to use the bag. So we'll do that. Look at that. Got even open. We're going to open this. We're going to attempt to open this. We got this open. All right, now, if you notice here, it says do not overfill. You want to fill it between the two lines. And then what Bob will do is Bob will take this and open it. One end of this. Okay, he's going to open this up like such. Yeah, all right. He's going to take out his pouch. There it is. He's going to put the water in there. Now, he hasn't done that yet. He's going to put the water in, slide this thing down into there, fold that over the top like that. He's going to insert that back in the cardboard box. Now the cardboard acts as insulation. That keeps all the heat in. Now he's supposed to, according to step 5 here, he's supposed to keep this thing balanced up like that on a rock or something. Well, we don't seem to have a rock here, so I got to look for some other semi-useful object to prop this up on. Oh, semi-useless. An old math book. Ah, there we go. All right, well, we'll prop this up. We'll let Bob here take care of this end of it, and I'll go show you the chemistry. All right, take over, Bob. As you can see, Bob and I have removed the polyethylene matrix from the heating pad from the flameless ration heater. Now, according to the papers, this should have in it magnesium, iron, sodium chloride inside this plastic matrix. Well, Bob wanted some definitive proof that that really is true. So what I have here is these are neodymium magnets taken out of hard drives that Bob and I salvaged when we took them apart. So we're going to see if there really is iron in there, because if there's iron in there, iron is magnetic. Magnesium is not. So, look at that, Bob. Look at that. Definitive proof it really is in there. Iron really is in the matrix. We'll put it back. Here you can see the granular magnesium and iron alloy and the salt crystals together. Bob wanted definitive proof that there was iron in there, so we used a magnet. Well, let's see if we can prove that there might be magnesium in there also. See sparks flying off? That's the magnesium burning. And that's my tongs burning. Oh well, things happen. Bob wanted some definitive proof to see whether this had magnesium in it or not. So what we did is we piled some up on top of a flame-proof, heat-resistant top here. And we're going to hit it with a torch and see if we can see some little white sparks fly off to tell us that there is magnesium present. There we go. There we go. See those sparks? That's the magnesium. All right. There's proof. Okay, Bob. More proof. Bob's back there finishing up the meal. While he's doing that, I'm going to explain the chemistry of this. The basic overall chemistry is really magnesium mixing with water, and you're producing magnesium hydroxide plus hydrogen gas. You could actually hear the hissing coming out of the bag once the reaction got started, and a lot of heat. And you can balance this and you can figure that out. A couple of things you want to look at here that makes this really interesting is this. Remember that hydroxide, you see hydroxide up here in the reaction, is the smallest polyatomic ion. That's the smallest ion made up of more than one atom stuck together. So water is really not just H2O, it's also hydrogen plus hydroxide. Now, if you look at that, hydrogen is on our electromotive series of metals, so is magnesium, so is iron, and so is sodium. But look at the order that they're in. That's what makes it interesting. Here is sodium. It's the highest one. Hydrogen is the lowest one. And magnesium is very close to sodium, very high. And iron is somewhere in the middle. So if you remember that order, that'll help you understand what's going on here a little bit better. Okay? So if you notice up here, you don't see iron in the reaction. But what iron does, iron in this case acts as a promoter. It's not really a catalyst, but it's a promoter. It actually helps make some what are called intermediate steps between the plain magnesium and the magnesium hydroxide. It actually works at the surface of magnesium to help break it down. And then comes along salt. Salt destabilizes the coating on the magnesium to allow the iron to get in there. And by taking away the hydroxide, because remember, sodium was higher on the electromotive series of metals than any of the others, so it can take whatever it wants, and it wants the negative ion. So once it takes it, then what happens is it redissolves into water, and it goes back and grabs another one, and it just keeps doing that, and that keeps exposing more magnesium to more water, so the reaction just keeps going and going and going. Henceforth, why you get lots of heat. And that is why, in this situation, iron is a promoter, but sodium chloride, sodium, is an actual catalyst because it never gets used up. All right, I'm going to go back and see how Bob's making out, see how our lunch is coming. Here we go, Bob. You ready to eat? This is what we referred to earlier in the year as technology. Take a simple process like the rusting of magnesium and figure out a way to make it useful. What's more useful than giving people hot food if they're out in the rocks and weeds or if they're stuck in a garage? So, let's see what we got, Bob. That is really warm. Take that out. Take a look at this. If I can open it up, which I don't think I can. I don't know what I'm doing. No idea. Where the heck is the top of this? There we go. Can't even get something out of the bag. Oh, look, a good use for a math book. Here we go. Here it is. All right. Oh, man. Better squish that down to the bottom. Open this guy up. There you go. And there is beef ravioli. Looking good in there. Okay. All right, Bob. Well, bon appetit, Bob.